So now we've looked at the general polynomials, and we've looked at how to use the polynomial function when we were dealing with our honeycomb. So now let's move into a little bit more general and abstract view of polynomial functions. So if we take, say, our p of x, and we've got our function x to the fourth minus x to the third plus 3x, then we would want to find such a function or a value of p of 2. So just like we were doing with our honeycombs, we're going to take this value of 2, and we're going to put it everywhere the x goes. So that makes it going to be 2 to the fourth minus 2 to the third plus 3 times 2. So 2 to the fourth means 2 times 2 times 2 times 2. So 2 times 2 is 4, and 2 times 2 is 4, so 4 times 4 is 16. So 2 to the fourth is 16. And if we look at 2 to the third, well, that's 4 times 2, so that's going to be an 8. And then 3 times 2 is 6. Then we can go ahead and solve our order of operations problem here. So 16 minus 8 is 8 plus 6, which would give us 14. So it would be a very basic application, like a pre-algebra application of functions. So we want to move more abstractly into our Algebra 1 application. So if we had, and we filled in a variable instead of a number in for x, so we say p of y cubed, then we're going to take this y cubed, and we're going to put it everywhere the x lives. So that's going to be 2 times, and then we're going to put our y cubed in there to the fourth power, minus our y cubed to the third power, plus our 3 times our y cubed. And I tend to put parentheses around it whenever I start dealing with our variables to make myself very clear on what it is I'm actually multiplying and what I'm taking to an exponent. So order of operations says take care of my exponents next. So if you take an exponent to an exponent, you actually multiply. So this is going to be 2y to the 12th minus y to the 6th plus 3y cubed. And at that point, we have no more like terms, and that's as far as we go. We have another expression, just our exponents are a lot larger. So that would be our Algebra 1 application of this. So now let's move into our Algebra 2 application of this. And it gets way ugly. So again, we are going to be taking and putting in whatever is inside the parentheses in for our variable in each case. But this time I'm going to have to do it multiple times. So I'm going to do red for my first part, and then I will switch to blue to take care of my second part to kind of keep them straight. So the first part is I want to take b of 2x minus 1. So I come down to my b, and I know that this is going to be, and why don't I do them separately, and then I'll put them back together. So I put my 2x minus 1 anywhere my m is, and just rewrite it. And again, this is going to be on the slightly ugly, hairier side of things. So at this point, I look and I see that I've got 2x minus 1 squared. And no, we can't just square the first term, square the second term. We have to actually FOIL this. So I tend to write a 2x minus 1 next to it to remind myself to FOIL because I have my square there. So I'm going to rewrite my 2 from the outside. And then I'm going to FOIL. So it's 2x times 2x, which is 4x squared. And then it's 2x times minus 1, so that's minus 2x. And then it's minus 1 times 2x, so that's my negative 2x again. And then I've got my minus 1 times minus 1, which is actually a plus 1. And then at that point, I can add my 2x minus 1 minus 1. From there, I want to distribute my 2. So I'm going to take my 2 times the first term, second term, third term, and last term. So that's going to be an 8x to the 4th minus 4x plus 2. And then bring down my plus 2x minus 1 from up above. Now I can combine all of my like terms. So that's going to be an 8x to the 4th. And then I've got minus 4x plus 2x. So that's going to be minus 8 minus 6x. And then this minus, or this plus 2, and this minus 1 would make that just kind of drop out. So if I have 2 and I minus 2, I'm at 0. So that takes care of my first part, my b of 2x minus 1. Now I'm going to subtract 3 times b of x. So let me switch to blue. So minus 3 times b of x. B of x means I'm going to take an x and put it everywhere the m is. So that's going to be a 2x squared plus x minus 1. So then I need to distribute my 3. That's going to be minus 6x squared minus 3x plus 3. And I want to bring down the first part of this, which is the 8x to the 4th minus 6x. And then I can combine my like terms and put it in order from least to greatest, from greatest to least with my exponent. So my 8x to the 4th is my biggest. Then I look through and I've got a 6x squared. After that, I see I've got a negative 6x and a negative 3x, which would make a minus 9x. And then I have my plus 3. So after all of that work, that is my final answer. It is a term of degree 4. And I've taken care of both the first part and the second part and distributed my negative sign as I needed to with my 3.